Very good afternoon, students. Now, in the previous session, we have discussed about the various parameter of measurement for the screw thread. So, in that, we have gone through the various method for measurement of inner diameter of the internal screw thread. Right. So, there are two method by which we can measure the diameter, right? Internal diameter. One is called a taper parallel, and second method is the roller method, right? And then we have gone for the internal diameter measurement by means of this setting gauge method, right, of the micrometer. So this is what a minor diameter of minor diameter of external screw thread is measured. Then a internal diameter of internal thread or minor diameter of internal thread is measured by two way. So this is what we have discussed, how we can get the answer. Here a limitation of these two methods is that when diameter is less than 20 mm, right, the use of taper parallel can be done and micrometer is used. Next method can be used when diameter is more than 20 mm, right, is the roller method. Then we have seen the measurement of effective diameter. So there are four various methods: one wire method, two wire method, three wire method, and a micrometer method is there, right, for the measurement part. So here we have started with one wire method, but now we have to go with a two wire method and three wire method that is remaining. But before that, right, we have gone through the best wire size, right, that we can use for the measurement of effective diameter. Then we have gone for the pitch measurement and all that things, right? And we have also seen the profile checking, right, of the screw thread by using profile projector. So up to this, if you have any query, you can ask, or else now we have to go with the important method, right, in which there will be a derivation. So it's a theoretical method to check the effective diameter of a screw thread. So is there any query from your side? Okay, so now we are going with a next method, which is two wire method. Okay, so first try to understand what is actually two wire method and how we can find the effective diameter, right? So derivation will be there that you have to note it down. So here you can see, right, two wire means a two non-diameter size of wire will be taken and it will be kept on the opposite side of the screw thread, right? We cannot keep both the wire on one side, but one wire will be on one side, second wire will be on the opposite side. And then we have to take a measurement by using micrometer over this two wire. Now, right, up to the downside of wire, this distance, right, that we know and that we can measure by taking a measurement through the micrometer. So this distance will be known as dimension under the wire. Our target is a measurement of effective diameter, and we are assuming that wire is coming in contact with the flank of screw thread on the pitch circle line. So that is what called a E, which is effective diameter. So gap between this T, which is dimension under wire, and effective diameter of screw thread will be a total P. It means a P by 2 distance on the upside and P by 2 distance on the downside. Right. So our task is we have to find out this distance P. Right. And when we add it into the dimension T, we get the answer of effective diameter. So here you can see, right, if the size of wire is such that it contact the flank at the pitch line, it is called the best size. And for that we have derived the formula also, right, in the previous session that we can use, right? So best wire size is selected, right? Best wire size is selected, which we can determine by geometry of screw thread. So for that, right, we have a formula also, and we just have to put the data. So here now see the clear picture, right? You will get idea. So as we know the diameter of wire, we can just subtract the 2 times diameter of wire so that we can get the answer of T. So it is very simple task, right? As we got the maximum dimension which is over the wire, and it is defined by a letter M. And here in between that two part, this will be the effective diameter that we have to find out. So in between the letter T, which is a dimension under wire, and the effective diameter line, a gap is of a P. So what is actually this P? So our total effective diameter will be a T plus P. So now our task is we just have to find out this small distance. And for this small distance, we have to derive a formula. We have to find out it, right? So task is very simple, but we have to find it out. And then we'll get the answer of effective diameter. So what is actually this distance P? So total it is a P distance, right? So half on the upside and half on the opposite side, right? So it will be a P by 2. So actually we will find a P by 2 distance, right? So T means it is the M minus 2D, as I told you, right, to get the answer of this small t distance. So when we have a right a dimension over the wire, we have to just subtract the 2 times diameter of wire, and we'll get answer of this dimension under wire. So only just P distance is required to find out. So P is a value which depends on diameter of wire, pitch, and the angle of screw thread, right? And M is the dimension of right over the wire. So how we can find this distance P? That is what our task first. So see here. So this is what a final answer of P for the various cases, right? And how we can go for that, how we can get it, that you have to see. So here this is what the answer of P, right? P means that is what you can see here. It is a P by 2, and that is what we have to find out. So the value of P for the Whitworth thread is 0.9605 P dash minus 1.1657 times D. And for the metric thread, the value of P is 0.866 P dash minus D, where D is the diameter of wire. So this is what right a formula we have seen. Remember this formula for effective diameter, it is T plus P. And here this P is not actually a pitch, right? But it will be a distance that we have to find out here. Right, so P is the difference between effective diameter and the dimension or diameter under the wire. So P is the E minus T. So how we get this T, right? So this T distance is you can see here, this is the formula to find out the T. It can also be found out by using this formula S minus R1 minus R2. That is what we have seen when we have measured the minor and major diameter. Okay, now we have to go for a process. So here is what right we have considered one side single thread in which arrangement of wire and everything will be solved. So this circle is nothing but it is a wire which is intersecting on the effective pitch circle line, right, on the pitch circle line, and that is what called a best wire size, which intersect the flank or which touches the flank on the pitch circle line. Okay, now see whatever things available on the upside, same thing will be there on the another side, right? So here you can see a diameter T which will be the up to under the wire, and effective diameter line that you can see here, this will be the effective diameter line. So only this amount of gap here, you can see this AQ distance which we have to find out, right? So number of things just we have to consider, same what we have done in the gear part, same we have to do here. Like we just have to consider different triangles. We have to apply right a different trigonometric function, and we will get the answer of this distance AQ. So can anyone give me suggestion how we can find this distance AQ? And remember the thing, right? This pitch circle line means here actually our effective diameter line will be here, right? As our line is intersecting pitch circle line. So our BQ point will be there right at the point D. How we can find this distance AQ? Okay. So now see the point, right? It is very simple. We know distance from O to A. So what is distance O to A? What is distance OA? Distance OA. Yeah, exactly right. I got answer. It is radius of wire. So that we know, right? A radius of wire, because we know, right, the diameter of wire, which is a known to us, because we have to select a wire, right, for which we know the diameter. So we know the radius. Now our point is, if we find this distance OQ, if we find this distance OQ, and if we subtract it from the OA distance, we get the AQ. Right, this is one option. Second option is, if we have distance PQ and another one is distance AP. So if we subtract AP distance from PQ distance, we will get the answer of QA. So we have to apply some logic and we just have to find out this distance. Our answer is over. Our task is over. So what we can do here? So here you can see in the second figure, I have considered one triangle which is triangle PQC. AP can be found. Yeah, exactly right. One answer is. So we just have to find out AP. Right. It is somewhat easy for us to find it out. So let's try right to do the procedure. So I have considered one right angle triangle. So that you can see here. I have considered triangle PQ See, now remember the thing, right? If you think that theory is hard and confused, so remember the thing, we want a vertical distance AQ. So whatever formula we will apply, right? We have to cover the vertical distance, right? So that any relation we can find and we can get the idea about the distance AQ. So here our target from this triangle is we have to find out distance PQ. So should we know about distance PC, or do we know about the distance QC? Is any distance known to us? Yes, one angle is known to us, that you can say this half thread angle is x by 2. Right, this half angle is x by 2. You can consider it is theta by 2. Right, anything will be there. But angle is with us. We want one side. If we have one side, we can find another side, right, by using this angle and a length of arc, or by applying the sine cos formula. So is any length known to us? Yeah, exactly right. One answer I got is a distance QC, that we know. So QC is nothing but, if you will draw another thread here, and if you will extend this line, and if you will again take one vertical line from the center part, so this will be the, right, a starting point. If we take, so one arc, second arc, third arc, and right, maybe a pitch will be over in the center. If we consider from the starting point, so from this point to this point, likewise four partition is having, that happening here. So simply QC distance is nothing but, it will be P by 4. Right, okay. So now let's see how we can find first distance PQ, as we have angle and one side. So here you can see first, BC is the half of pitch. So here our task is, value of P is nothing but 2 times AQ. So how we got AQ? So here you can see the formula we have used this. It is PQ minus AP. See into the diagram and tell me, is it correct or not? Is it correct? We want AQ. Okay. So our task is, right, to find out AQ. We want PQ and AP. Do we have any answer of PQ or AP? Right now it is not there with us. But the point is, we have to find it out. So first we have considered one triangle from which we get the answer of PQ. So how we can get it? So as right suggestion I got from your side, we have to consider triangle PQC, and in which we want a closer side and opposite side is available with us. So we have to apply formula of tan theta. So here it is, tan x by 2 is equal to QC, which is opposite side, upon QP, which is closer side. Okay, so tan x by 2 is equal to QC upon PQ, where QC is the P by 4. So here the answer of PQ is QC upon tan x by 2, or we can say tan theta by 2. And we know 1 by tan theta means, 1 by tan theta means, yes, exactly, it becomes cot theta, right? Cot theta. So here PQ will be P by 4 into cot x by 2. PQ is equal to QC, sorry, cot, yes, QC cot x by 2. So here the answer of QC is 1 by 4th of circular pitch. So our final answer of PQ is, but here see, actually we are going to find out a distance P, right? We have to find out distance P. So here this P dash is actually a pitch distance, and that's why it is defined by the P dash, as we have to keep it separate from our P value that we have to find out. So P dash is the circular pitch, right? So here our final answer of PQ is P dash by 4, P dash by 4 cot x by 2. Okay, so one answer we got for the PQ. Now we have to find out about the AP, that is required to find, and we just have to subtract it from this formula. So how we can find distance AP? Is there any suggestion? how we can find distance AP. What do you think? Okay, it will be effective diameter minus AQ. But see, our task is to find out effective diameter. We don't know, then how we can use this relation. So whatever procedure we are doing here is for finding out effective diameter. See, focus on the diagram, you will get some hint. Can we use this relation from O to P? Okay, so let's see what we can do. So here you can see another triangle that I have made, which is again right angle triangle, triangle OEP, triangle OEP. So what we can get here from? So our task is we have to find out distance OP because we know about OA. So when we subtract OA from OP, we get answer of AP, which is very simple thing, right? Yeah. OE is again, we also know about the distance OE, which is a radius part, right? So we know about this side, angle is also available with us. We just have to find out OP. So what we have to apply here? Sine, cos, tan. We want this vertical side OP. We know the OE distance. So OP is the hypotenuse and opposite side of angle that we know. So what we can use here? No, tan theta can be applied when we have a closer side. Here you can see right angle is at O. So these are the two closer side. OP is the hypotenuse. So remember the thing guys, wherever hypotenuse is there, if we simply take, then sine theta or cos theta will be used. Because sine theta means it is opposite side to hypotenuse, cos theta means it is closer side to hypotenuse. So we have a opposite side of angle is there. It means we have to use sine theta. Okay, so let's see about how we can find the OP. So our next task is AP is equal to OP minus OA, right? So that we can get AP. So here the point is we want OP. So for that we have considered triangle OEP, and where OE is the radius. So our next step will be sin x by 2, which is OE upon OP. So OP is equal to OE upon sin x by 2. It's not OE upon AP, it's OE upon OP. Yes, right. So now here you can see we want OP. So I just have reversed the equation. So OP is now in upside and OE is in downside. So same way on same right on the left hand side, 1 by sine, and when there will be a 1 by sine theta, it becomes cosec. 1 by cos becomes sec, right? So remember these relations, it is easy for you to solve the formula. So 1 by sine, it becomes cosec theta. So here it is cosec x by 2 is equal to OP upon OE. So now OE is multiplied here. So what is the final answer? So now OP is OE into cosec x by 2, and that is why OP is d by 2 cosec x by 2. Answer of OP is d by 2 cosec x by 2. Right. So guys, try to understand the situation. Right. One by one, we are finding the required parameter. So it is easy for you to remember the theory. So OP that we got. Now we want OA. So as we know, right, OA is nothing but simply it is a radius of wire, or we can say, right, it is a diameter by 2. So we can get AP. Okay, so now first let's to find the answer of AP. So you can see AP is OP minus OA. It will be d by 2 cosec x by 2 minus OA is also radius, which can be written as d by 2. So d by 2 will be common. So when we take d by 2 common here, what will be the final answer for AP? It will be d by 2 in bracket cosec x by 2 minus 1. So here is the answer of AP. Right, this will be the final answer of AP. Okay. So we have an answer of PQ. We have an answer of AP. So now easily we can find the answer of AQ, which is our P by 2 distance. Right, this will be nothing but it will be a P by 2 distance. We just have to multiply it by 2. We get the answer of complete P. Okay. So see here, our AQ is PQ minus AP, and now we have a formula of PQ as well as AP that we have already found by using two different triangles. We just have used two triangles, right? Not more than that. So we just have to put the value here, right? And AQ is nothing but it is half of the value of P. So P will be 2 times AQ. So it is 2 times PQ minus AP. Put all the formula, you will get answer. So this is what PQ means P dash by 4 cot x by 2. AP means D by 2 cosec x by 2 minus 1. Apply this 2 inside the bracket. So here it will be cancel out. So remaining part will be 2. And here 2 will be cancel out with these 2. So now what is the final answer for the P? Right. So this is what the final answer of P. And this is the general formula applicable to any kind of threads. So final answer of P value, final answer of P value is P dash by 2 cot x by 2 minus, here D is only a remaining part. So D into cosec x by 2 minus 1. Right, this is what a value of P. And when we add the answer of T that we got from the measurement, right, our final answer of effective diameter will be there. Okay. Now see, as you have seen in the previous slide about the two different kind of thread. One is a Whitworth thread and one is the metric thread. So what about it? So for metric thread, remember the angle, right? A theta is 60 degree, but here, right, it will be a theta by 2. It means x by 2. So for metric thread, if you want a value of P, so what you can do here, wherever you can see x by 2, right, or wherever you can see x, put it here 60, right? All other parameter will be as it is. So it will be P dash by 2 cot 60 by 2 minus D here cosec 60 by 2 minus 1, right? And 60 by 2 means it is 30. So find the value of cot 30 and cosec 30, right? And do some simplification. So our final answer of P value for metric thread is 0.866 times P dash minus D, where small d is the diameter of wire, right? So is it clear? We just have to find out value of P, right? So as we got the value of P, our final effective diameter will be E is equal to P plus T. And value of T can be found out by using that final measurement done by the micrometer. So is it clear? Okay, so we'll go for next method. See, remember this method, right, as it is important one. Maybe a formula or based on formula, right, example can also be asked. So next method is three wire method. So again, see, just change in three wire method is, see, the main limitation of two wire method is only a single wire available on both sides. It means both the wires are available on the opposite side in the cross connection that you can see here. I am going to show you. Right, you can see both the wires are available in cross connection. So there might be a chances of slipping of micrometer surface, right, or there will be an inclination problem. So we will not get the exact result, right? There will be some issues by right in taking a result. So the point is just to give the stability, right, to the instrument for proper measurement. We have to go with a three wire method. Otherwise, everything will be same. So first see it, what is actually a three wire method. So according to this diagram, you can see on one side we have a one wire, on other side we have a two wire, right? It is not necessary that two wire can be keep on the downside. You can use two wire on the upside and one wire on the downside, right? But now the point is when we use this two wire, we can have a stability, right, for the measurement, and we will get the perfect or proper measurement, and we will get the accurate result. Okay, so now the point is, as we have find out the effective diameter by using two wire method, so now it is not right a desirable thing to go for measurement of three wire method, because otherwise the same measurement, the same process we have to follow, right? And again we will get the same answer because we have not done any kind of change in terms of geometry or anything. So now here our task is we will find this outer diameter, which is m, right? Because the outer diameter practically we are finding it, but theoretically also we have to see, right, is it answer, right, that we want or that is available? Is there any deviation in the practical and theoretical result? Right. So our task in three wire method is to find out this dimension over the wire. So here you can see up to this particular point, this will be the effective diameter that we have already find out. Right. So we just have to find out this upside distance. So this distance on one side and same distance on the downward side is required to find. And we will get the answer of dimension over the wire. So in this method, three wires of equal and precise diameter are placed in the grooves at the opposite side of the screw. In this, one wire on one side and two wire on other sides are used. So the wires either may held in hand or hung from a stand. Right, so that depends on the operator how it is, right, holding the wire on the screw thread. This method ensures the alignment of micrometer annual faces parallel to the thread axis. It means a more accuracy of result will be available. So this method, see here the benefit of this method is, right, this method is more accurate than two wire method as it ensures alignment of micrometer faces parallel to the thread axis, parallel to the thread axis. Here three wires of exactly known diameters, right, three wires of exactly known diameters are used, one on one side and two on the other side, right. Wire may be held in hand or hung from a stand. Now let's see how we can go for measurement. So dimensions, right, will be same as you have seen in the previous method. E will be the effective diameter, right. M is the diameter over the wires. Then D is the diameter of wire, small d. H is the height of wire center above the pitch line. So that you will see the figure, you will get idea. R is the radius of wire. Capital H is the depth of thread. Now here it is required to mention and we have to use it. And capital D is the major diameter of the thread. Right? Major diameter of the thread. So how we can find the major diameter over the wire? So here we just have to consider this figure. So here you can see that this will be the wire and this will be the effective diameter line. So up to effective diameter line, we know the answer that we have found from the two wire method. Now what actually we are going to see here, or what we are going to find here actually. So this distance we are actually going to find, which will be the diameter over wire or dimension over the wire M. So our task is, suppose here it will be a letter G. Here it will be a letter G. So our task is we have to find out distance from C to A and from A to G. So this complete distance C to G is required to find. Now again see, half distance that we know from A to G stop point G. What is the distance AG? What is distance AG? Simply we know, right, A is the center of wire and G is the end point. So it will be a exactly, right, radius of the wire, and that we know. So it is not required to find. So only now our task is we just have to find out distance AC. So how we can find it? For that we have to do some procedure. Because AC distance is not known to us. So what we can do is, so for that first we have considered this triangle ABD. Here you can see the triangle ABD. Because ultimate try is, if we have answer of AD and a CD, we just have to subtract CD from AD and we will get the answer of AC. So here you can see this half angle is theta by 2. AB distance, that is radius of wire, which is D by 2, that we know. So easily we get this vertical distance. And again, why we are finding AD? Because we want vertical distance, right? So here you can see we just have to apply sine theta because we want hypotenuse and opposite side is available with us. So sine theta by 2 is equal to AB upon AD. And we just want AD distance. So I just have reversed the formula. So AD will be on upside, AB on downside. Sine theta will also be gone into the denominator part. So it will be a 1 by sine theta is cosec theta, as you know from the previous formula. Right, so it will be a cosec theta by 2. So cosec theta by 2 is AD upon AB. So AD is equal to AB into cosec theta by 2. And AB that we know is D by 2. So final answer of AD, right, what we get final answer of AD? It will be D by 2 cosec theta by 2. Okay, so we got answer of AD. Now we want answer of CD. If we have answer of CD, then our task will be very easy. So how we can get it? Is there any suggestion how we can get it? So CD distance that we can find from here, right? We have to use this triangle. Now how we can use it and what we have to do here? So just see it. We have to consider this right angle triangle. And what happened actually here? So here you can see, right, from top point to this point, it will be considered as a depth of thread. It will be considered as depth of thread. No, right, we have not find any relation for the point C. Right, one line that is below this circle, one line from center to this part. So now here we have to go with this particular relation. So here, this is what called a capital H is a depth of thread. So here if we consider this point C, so C is nothing but it is at the half point of this thread. It is the half of the thread part. So how we can find, right, this distance AC, as A is on the right up part. Okay, so let's see. So here you can see that we have considered another triangle here. So first this vertical line is known as E at this top point, because see, don't say that A is the center of this, sorry, A is up to the peak point of this part. A is different, right? It is somewhat away from the top point of the screw thread. So here it will be line E, D, F, right? This is what a triangle we have to consider. EF is the half of depth of thread. This half part you can see will be the small h. How we can find this distance CD? So if we have answer of this capital H, we can divide it by 2 and we will get the answer of EF. So what we have to do here? So for that we have considered triangle DEF. So angle is available with us. We want EF distance. Do we know about distance ED? What is distance ED? So this complete distance, right, between these two parts is considered as pitch. And E is at the center part of this line. It means it will be a pitch by 2. So ED is nothing but it will be a pitch by 2 distance. Right, it will be a pitch by 2 distance. Okay. So now here you can see how we can find it. So opposite side we know, closer side we want. So we can apply tan theta. So here it will be a tan theta by 2 is equal to DE upon EF. But we want EF, which is our vertical distance. So we just have replace it. So 10 will go in the denominator part. So it will be 1 by 10 means it is cot theta by 2. So cot theta by 2 is equal to EF upon DE, where EF is our height. EF is our height. So it will be H. Height means it is a depth of thread by DE. So H will be DE into cot theta by 2. And where DE is right, I told you here, DE will be pitch by 2. So final answer of H will be P by 2 cot theta by 2. But we are interested a distance, right, from this point to this point, which is equal to distance CD, and that is half of capital H by 2. So now we have answer of capital H, which is P by 2 cot theta by 2. So distance CD, right, distance CD is equal to H by 2. It means it will be a P by 4 cot theta by 2. Right. So final answer of CD will be P by 4 cot theta by 2. Is it clear, guys, how we got the answer of a distance CD? See, wherever any query you can ask. Is it clear now? How we have found this distance CD? Okay. Then next, see, we have seen about the, right. So remember the point about this Whitworth thread and for metric thread, as we have discussed, like what is the effective diameter formula, what is the dimension over the wire formula. So here you can see, right, for effective diameter for Whitworth thread, the formula is D minus 0.64 times P, and effective diameter formula for metric thread will be D minus 0.6495 times P. Okay. And this is what, right, we have discussed about the best wire size, right? So this is the formula for best wire size diameter, which is P by 2 sec theta by 2. Then we have gone for the measurement of thread angle, right? So there are two methods. One is called a profile projector method, and a second method is a protractor arm, right? A vernier protractor method. Then pitch measurement by the pitch measuring machine. So this is what we have discussed, and these are the some standard pitch gauges, right? So only one point is remaining to discuss in the unit is error in the screw thread. So that we'll see in the next lecture. So up to this, if you have any query, you can ask, or else we are going to end up this session. And then we have to go for a next unit. Okay, so now you can leave the meeting if you have no query. Thank you very much. Have a nice day.